Assalamu alaikum and welcome to another part for chapter number 10, which is very important chapter for uh, C language, and that is related to structures, unions, and type def over there. And overall, this chapter is not that long, but the concepts inside this chapter are actually going to be the basis of the object-oriented programming, which you are going to do in your next courses to follow on, or the courses after this one, supposedly if you are going to learn about the data structures, algorithm, and all that. Now, these are some heavy words which I'm using at present, so I will try that these are explained over here. And for that purpose, I'm going to give you some examples over here, and we are going to talk about in detail. Now, before I move on forward, let's just see, first of all, chapter number 10 actually includes what the contents over there. Chapter number 10 has something about structures. Now, what does a structure? I will talk about this in detail and I'll give you some examples as well. Then how you are going to declare them and initialize those structure variables over there. Now, these are something, a different type of variables. Up till now, you have been aware of variables such as int, float, array, well, not array, actually array is just like a subtype actually, because array can be about of int as well, it can be about character as well, it can be float as well. And then how you are going to initialize structures, how you are going to access those structure members, and then how you are going to use those structures with functions over there, and then the type def. So basically this chapter is mostly about the structures and type def and unions. The other thing which is actually important, which I will be discussing in the next part, is actually the bitwise operator. In fact, maybe the part 2 will be carrying the unions and bitwise operator. And we are going to just do like 4, 5, or 6 of these topics here in the contents over there. So today topic we have called about structures. Now, before I go on towards the structure part and discuss it, what does a structure mean over there? Now, up till now, inside C language, you have been storing data in their data types. And those data types have been integers. You have been using unsigned int or signed int. You have been using float. You have been using double. You have been using a character or maybe a string. Not a string is not a data type, but if you store it inside a memory, you can point it out using a pointer. So that's the type over being used over there in C language. Now, the problem with this is this, that they take a lot amount of space inside the memory. And whenever you are going to store the data, you have to keep record that where you are actually going to store all the data and which variable is pointing out to which one. For example, let me give you an example over there. Supposingly, if you have a class, just like your class section A or section B, and inside that class, you are like 50 students per section. Now, supposingly, you are not studying just C language over here in the course Programming Fundamentals. You are also studying a course of AICT. You're also going through a course of discrete mathematics, also having a functional English. So, supposingly, if I want to store your marks, which you have scoring inside each one of these subjects, then I will have to remember the variables which are actually going to. Supposingly, there is a person named over here. Let's just talk about your CR over there, or maybe not the CR actually, or anyone having a name Sn over there, and that Sn has going to store it inside a variable called Sn. Now, if I want to store Sn's marks, which he has scored inside your programming fundamentals, then I will have to name that variable as Sn underscore PF underscore mid. That will be the midterm marks. And if then I have to store it, supposedly for its quiz marks, then it will be Sn underscore PF underscore quiz 1. If I have to store for quiz 2, Sn underscore PF underscore quiz 3. In the same way, if there is another student, supposedly other than Sn over there, if there is another student over there, let's say talk about the GR, Zanab over there, and Zanab number has to be stored, then Zanab underscore PF underscore mid, Zanab underscore PF underscore quiz 1, Zanab underscore quiz underscore, PF underscore, and similarly for all other subjects as well. Now, this makes the number of variables so much, it's very difficult. Now, since you are going to be 100 students over there, it will be very difficult to store them, remember those variables, and then to when you are going to access them, when you want to print them, supposedly my program wants to print the marks of all the students' midterm marks, then I will have to like down 100 lines over there. Now that's something very difficult. So to avoid it, we normally store the data in C language in form of structures. And what that structure means, supposingly, if I want to now store in form of structures for your class, section A, supposingly, and again talking about that student S1 over there. So inside S1, I will construct a structure, and inside that structure, I will name it supposingly S1. Supposingly, I will name it S1. And inside that structure, confined by a boundary, and inside that structure, I am going to have a variable called as supposingly integer, and it will be called as registration. Done. That will be holding the registration number of SN. Then I will be having an integer variable called as PF over there, under PF or mid mark something, or supposedly whatever, int over there. Now, when I'm going to initialize this structure, it will be having a inside variable of for the registration number, for the roll number, for the marks of midterm, for the quiz marks, for AICT course, for discrete mathematics, or any other courses. Now, when I've made this structure, I will initialize this structure for every student inside the class. For what this means that I will be actually now initializing this particular structure for SN as well, for Zainab as well, for Laiba as well, or for any other student that is going to be over there. So in this way, I can access that structure for that particular student, and then I can go inside it. So this means I will be having something like this. Let's say go on the next slide over there. So previously what you are having, now see this slide, this is something very, very important. Now previously, if I wanted to have the name of that essence stored over there, I will have to have a character array, and that will be storing the name of that essence, whatever the second name or the last name would be. And then I will be having an integer for the age, then I will be having for your GPA, then I will be having some ID here. This is an ID written, it can be registration number or something like that. So this, and then you can have more other types over there. Now in this way, this is without structures. Now if I want to give it as structures, I am going to group related data together. And what I'm going to do, the word is struct, smaller form for structure, struct student, bracket open, and inside the brackets, which are actually here the curly brackets over there, I am going to name the same thing which I want to do it, and this will be character name, int age, float GPA, character ID 10. So now what this happens, I have made a generic structure over here, and in this structure, now this data type can be applied for all the 100 students over there. Now, what this means over there, let me just go on. Now, one thing very important, this chapter number 10 from your book, which I'm talking about the detail, is a little heavy. And because of the concepts being used over there, it's a little heavy in English. So I will strongly advise you to go through these slides first, and then maybe these links, which I'm just going to discuss with you over here. And these links are something very, very important over there. Please go through them before reading that chapter over there, because personally, when I have gone through that book, it has a little difficult English, a little different concepts written in a little adjective English over there, so it's a little difficult. So I will strongly advise you to go through these links. I will post these links in below the link over here, or the YouTube link over there, or maybe on the website as well. So please kindly go through these links and the slides over there, and then of course, then you can go through the reading of your chapter over there, because that's a little heavy from the book's perspective over there. Now, again, coming on, structures, as I told you, structures are a group of several related variables in one space. Each variable in a structure is known as the member of the structure. Now, why it's a member of a structure? I have over here a struct. Name of that struct is this is the keyword or reserve word, you can call it, and I have called it my structure. And inside that my structure, I have an integer. I have called it my number, and inside I have a character variable. Of course, it's going to be just one single character, and that is my letter. So it can be just like, you can call it the grade which I'm going to assign over there or something like that. And this is that my number over there. It can be an integer number of integer data type over there. So now when I have named this structure, I've made this super data type. You can call it as a super data type over there, which has members of its own. So now I want to make one student or one member of this structure the command would be, now the command I'm going to do it is something, and remember, you have to make the structures out of your main function. This is very important. You have to make these structures out of your main function, and then afterwards inside the main functions, now you want to make a member of this structure. For that purpose, the command is struct my structure. Struct is again the same word, and then at the end you have written s1. So now what is this s1? This s1 is the name of the if of the structure data type. Just like you write down int x. What does x mean? X is a member of that integer data type over there. So X will be taking the properties of the integer data type over there. Similarly, S1 here will be taking the properties of the structure, my structure over here. And what does my structure has? My structure has internal two variables inside. So supposingly over here struct my structure S1. So S1 has inside two variables which are called as my num and my letter. So this is in this way you are now making it. Now in this way, I can add struct my structure S2 also. I can add struct my structure S3. And if supposing I want to repeat it to 100, I can do that as well. So now in this way, the relative members are grouped together inside this structure command over here, or inside this thing outside of your main function over there. Now, how you are going to put the values and access them, that's actually the point thing over there. Now, how you're going to access them? Now, again, going on the example, I will just copy this example also in my Visual Studio and just show you. But before that, I just want to explain this thing first. Same thing, given the structure, creating a structure called my structure. Here, int main, creating a structure variable of my structure. Now, so remember this thing, this is just like making just like a data type integer like over there, and here this is called as s1. So s1 will be having the data type qualities of my structure which has been defined over there, and inside it has two members. Then if you want to now access s1 and inside its quantities, so s1 dot my num is equal to 13. What you are doing over there, s1 is that variable which you are making over there, a structure variable of my structure type over there, and inside it has my number. So dot over here is the operator by which you are accessing the qualities or the members of that structure. Now, just to give you an idea, now since I'm telling you this point over there, another example just to make it easy for you, you are in Pakistan. In Pakistan, there are approximately 25 crore people or 250 million people over there. Now, since we are sitting in Punjab, so Punjab has approximately 120 or 130 million people over there, 13 crore people over there. And then we are sitting in Lahore. Lahore has approximately a population of supposedly like 3 or 4 crores, maybe 3 crores you can talk about over there. Now, when you are going in the Nadara database, now listen to this very, very carefully. When you are going in the Nadara database, where your all your CNIC numbers and everything is stored over there, they don't just haphazardly store your data. They store inside structures. Pakistan is the main structure. Inside, they have like 4 provinces, or you can call it the fifth province, with Gilgit-Baltistan or Azad Kashmir are also going to be part of us in the province over there. So there's going to be a structure inside 5 structures, and inside that structure, there will be another structure called as the districts, which are going to be called as Lahore, Rawalpindi, Multan, Faisalabad, Gujranwala. They will be the districts. And inside those Lahore and everything, supposedly in Lahore, you have union councils over there. And inside those union councils, you have some areas over there which are the delimitation of your regions. So your CNIC is going to be not just stored, or your name is not just going to be stored just in database. Your this number is this. No, it's going to be saved in form of structure. So similarly, if your number is entered over there in Nadra, you go to somewhere at Nadra station over there, and you want to find out, okay, you want to have a duplicate CNIC card over there. When you enter that, based on your number, it detects, okay, you are in Lahore. Okay, you are in that union council. You are in Lahore, it takes on to the Punjab, and then it takes on to whatever the region over there. And then it searches on that, okay, you are in that specific. That narrows down its search pattern. Otherwise, just imagine a computer has to find out a number from 250 million entries. Not possible. It's very difficult. You can't do that. Just imagine it out. Facebook or Twitter or someone, whenever you are logging in, supposedly they are like 40 million or 400 million customers of Twitter. Okay. In fact, like if I'm not wrong, Facebook had approximately 2 billion customers over there. Now you're going to log in on Facebook, how it's going to find out that this password is there, and it's going to find out, okay, this was the username, this was the password. No, it's going to find, okay, you are coming from Pakistan, you're coming from the Asian region, you are coming from the East or the West Asian region. So it will narrow down your search, unless and until you're using a VPN, then that's another case over there. It will take some time then to log in. Plus it will then search on based on your username which you have selected. Then it will narrow down that search to maybe like just a couple of thousands or maybe couple of lakhs. In Pakistan, the number of Facebook users will be limited, not like India or maybe not like America or somewhere else. So structures are very important. Similarly, for your sections in section A and section B, if I want to store your data, I have to make structures. And for that structure, I have to access those structures. The operator is dot. So here, this s1 dot mynum is equal to 13, s1 dot myletter. So here, supposedly, s1 was a student name, supposedly. So s1 has this my number, and then it has a my letter. And so I am accessing these ones. So by using the dot, previously, if it was not using this structure, then I would have to have s1 underscore mynum, s1 underscore my letter, s2 underscore mynum, s2 underscore. It will be so difficult. Now, using this dot operator, you can change it, and now you can access it. Now, the main advantage. Now, this is, remember, this is just one structure, and they are not substructures inside it. I will show you one example of substructure also. It will be a difficult one, but I will try to show you over there. Now, let me just copy this thing and show you inside the Visual Studio so that you can understand what I'm actually talking about here. So I have the Visual Studio over here, and inside this chapter number 10, remember chapter number 10, the examples here and the ones are not very good over there. In fact, they are talking about this cards and all that stuff. So I'm not going to discuss these ones over there. You can go through them yourself. I'm trying to give you, because this is a conceptual thing. Remember, this is a conceptual things. So you have to be very, very careful when you are going over there. Now, let me just change something over there so it's a little easy for you to understand. So here struct. So this is record. Let's say I'm just changing it over there, and this is the marks and character. And let's say I'm just changing the names over there, and this is going to be struct record. I'm just trying to make it in accordance with your class, and let's say I'm going to call it SN, the same over there, the marks and over there. So here this time this would be SN. Sorry, SN. I don't know if SN is some student in my class or not, so maybe he is there. So and then it will be marks, and this will be grades. So this will be SN. Now, totally remember, this is case, you have to remember the case over there. If you are using the caps lock over there, you have to use the caps lock over there, since I'm using that one over there. So this will be SN dot grade. So this is my part. So what I have done over there, let me just again rephrase it and tell you. Here, this is the structure called, this is record. Over here, I just change it so it's easy for you to understand, because I gave you the example starting this lecture or this part with telling you that a structure is actually combining r- group terms or variables over there. So you have int marks, character grade. Then I make a struct record sn, and sn dot marks is equal to 13, sn dot grade is equal to b, and I want to print it at, this will be simple sn. This is just like I ask you from where you are. So I ask you from where you are, you tell me your registration number. Then I ask you next thing, you tell me, okay, I am from supposedly Gujranwala. Supposedly, then you tell me, okay, from Gujranwala, which area you are, and then you tell me, okay, you are from Punjab, and then you are from Pakistan. So in this way, you are accessing structures over there. So let's just run this program and just see if this works or not. Of course, this should be working. So okay, I have done some mistake. Sn dot marks. I guess I have not done some mistake. Okay, undeclared printf should not be a mistake. Struct call to undeclared library printf. Okay, okay, sorry. Actually, I have not included stdio.h. Actually, that copied it over there. So stdio.h. So that's my mistake. So you can see now my number 13 or something, or let's say is you can call it SN number, SN letter. So if I just run it, this would be SN number, SN letter. So you are storing the marks and grades. This is just like a structure and you are storing it inside your memory over there. Now let's say just because just mid marks, let me just call it this is mid over there. Let's say I call it int quiz underscore marks. Or let's say I call it quiz one underscore marks. And now I am increasing, sorry, this would be like this. And since I'm going to take 3 quizzes of your course, so I'm just making it 3. And let's say this is 3 quiz marks, and this is a grade. So now, if I want to now have SN dot, let's say quiz one underscore marks, I can add, let's say he's been a good student, 16. SN dot quiz two underscore marks equal to 12 over there. No need to put data for every member. Supposedly he has missed quiz 3 or quiz 3 has not been done yet. So it can be done over there. And here I can now add another 2 terms. And here this would be SN number, SN letter, and this would be SN quiz 1 marks. And this one would be SN, oh, sorry. This one be SN quiz 2 marks. So this would be SN, and here I will have to change it to quiz one underscore marks. And this one would be, I can change this one quiz two marks. Now, one thing very important, if I just print that thing also, let's say if I print that thing SN quiz 3 marks, and since quiz 3 has not been initialized, so let's see what happens. So now when I'm going to print everything over there, now let's see what happens. And this prints, you can see quiz one underscore marks and quiz why they have not been why they are not printed. Okay, sorry. I've used a wrong format specifier over there. Sorry about that. Since I'm using C, that's why it's character. It has to be. So you can see now quiz 3 marks are printed over there. Now, question over there, think on it. I will ask you in the next part or maybe in the comment below. Why SN quiz 3 marks have been printed as 1? Since quiz 3 marks, they are a part of your structure. And here I have not declared quiz 3 marks. So how this is printing quiz 3 marks as 1 over there? Why this is initialized to 1? Okay. So this is the SN over there. Now, similarly, you have printed 13B, 16, 12 over there and something like this. Now, similarly, let's say I want to now assign another member to this structure. So now what I will do over there, let's say I am now going to make it, the word would be struct record, and let's say it will be Zainab. Zainab, I guess, is the GR. Sorry, I'm using your name Zainab over there because I remember your name and Laiba, I guess. Um, so now over here, I can change this to Zainab. I can change this to now Zainab. I'm now assigning over there. Let's say Zainab and Hassan, they both have the exact same marks over there. And I just assigned them. Now, if I want to print the values, let's say I want to print the values over there. So now I just make it Zainab. And now this time this would be Zainab over there. This is a little problematic because you have to change each and every, and but still you know that what you are doing over there. So again, you can see over there, this is, you can change it to Zainab, and again I'm changing this to Zainab, And this one would be Zainab. This one would be also Zainab. And similarly, this one would be also Zainab, and this one would be also Zainab. So now I have made two members of the struct, Hassan and Zainab. They're two different students over there based on their name over there. I've called it, and now I have assigned them same values. I can change these values over there. Let's say Zainab has a little better score on the mark side over there. Maybe in the quiz, she has also scored over here. And then say, just print it on. You can see now Hassan is printed. Zainab is also printed. Now here Zainab is printed as -16. You have to tell me why this is printing 1 here and -16 here. Is it random? Why this is printing random? Now, one hint it's be because the memory is allocated. Whenever you are making this struct command, the memory of that thing is allocated. It's already allocated. So how this value is being taken up? Answer this me in the comments. I will tell you, is it right or wrong? So I hope you have got the idea of structures. You are making structures to ease your storing of data or clustering up all the relevant variables under one name. That is called as a structure. And just to go on the website from which I am actually taking this thing, another example, you can see struct my structure, same thing I've just told you with SN as Zainab over there, and you can see struct my structure S2 over there. And what thing very important, inside strings, remember that string C is actually an array of characters, and unfortunately you can't assign a value to an array like this is a little problematic in structures in C, that in string you cannot assign it. So whenever supposedly you have a structure over there, you have a my num integer, you have a character my letter, you have a character my string over there. So in structure you have made a S1. Now inside the third member of this structure, which is my string, which is actually an array of characters. So here, if you want to assign it s1 dot my string is equal to some text, this will give you an error because assignment to expression with the array type, this is not allowed. However, there is a solution for this, and you can use string copy. If you remember from chapter number 8, there was a string copy command and assign the value s1 dot my string like this. So the way of doing it is be using str copy, and here you write down s1 dot my string and copy some text over there inside it. So here you have to use the function. You cannot assign it like this because this is not going to work inside C, because here this some text is actually a memory inside your code. So it can't be copied inside another memory location. So you have to use a function, which is over here, the string copy, str copy. This is from chapter number 8. So remember, whenever you are going to store some string, you have to use str copy. Then you can access it. You can access any character over there, any string over there. But remember, you have to use str copy over there for this part over there. Then if you want to now this is the next thing, very, very important. If you want to have a simpler syntax, if you want to have a simpler syntax, because up till now what you are doing, one, before the main function, you are making a struct command, struct record and whatever the members of that struct over there, and inside the main functions you are making the members of that structure over there, or you can calling it the objects. Now I'm using the word object over there. Okay, this is exactly the C language where you are, this is a class, and inside that class I am making an object. So SN is an object of this class, which is record. And why SN is a part? Because SN is studying programming fundamentals course. So he is a member of this class. And inside that class, these are the members or the variables which are a part of it. Because when he's studying this class, he is going to have marks, he's going to have quiz 1, quiz 2, quiz 3, or a grade which is going to be assigned over there. So, and if you want to avoid this, then a simpler structure is, or syntax is this, that after naming the structure, you can directly write down inside the curly brackets every value which you want, but in the same sequence over there that you have refined the my structure. So you don't need to write s1 dot that my num, s1 dot my letter, s1 dot my string. So you can do that in one line as well. Here this will be 13 going to my num, b going to character my letter, and here this string will be directly going on to this thing. Here you can apply that thing. Here you don't need to use a string copy because you are telling it, and this is defining the structure, or sorry, the member of that structure over there, and then taking on this text from the curly brackets over there. And then you can print it on as %d, %c, or %s, all those three by using the dot operator. Remember, dot is the operator which is accessing the members of that structure over there, or the members of that class, you can call it over there. Then if you want to copy structures very easily, you can have S1 and S2, and in the next command, you write down S2 equal to S1. You can do everything. So let's say if I want to do this, the very exactly very same over there, I have Sn and Zanab over there. Let's say Zanab, this is the Zanab structure over there. And here I don't want Zanab to be Zanab to be having exactly the same marks over there. So here, let's say I call it over there after this command, let's say I call it Zanab equal to S. So this one would be, so when I'm going to now print it, you can see now this is exactly the same. 13b 1612 13b 1612 So you can copy structure to structure over there. So you can have the exact same thing over there being copied by using a simple one over there. So this is just like, so this is like a super variable, and it has some sub variables inside. So you are having a structure combining all the variables, like variables of that particular record over there. And if you want to modify the values, you can even do that. I have already told you, you can use this one, the dot operator over there. You can use the string copy over there, and you can do this one. Please remember this w3schools.com link over there. I will share this link with you, so you can actually use this structure command and this link before going on towards the book over there, and you can change this one at any given time over there. So here you are copying the values to S2, and here you are changing the S2. So now when you are going to actually run this thing, let me just run this code over here, just showing you. So this will take some time because this is going to connect with the compiler. And here you can see over there, this is 13b some text, 30c something else. Here you made two structures same, but afterwards you have changed some values. So this is 30c something else. So you can see that even if you have made the two structures same, this means that they are copied. But again, afterwards, if you change it, that will be changed automatically over there. So same thing is being done over here in this one. But remember, the struct command has to be done before outside the main function over there. So this is something very, very important. Then let me just give you a real life example. And this is something very, very important. Here you have a structure outside the main function, car. Car can be of any brand, any model, any year over there. So here, this is the brand. So of course, the brand, it can be Toyota, it can be Honda, it can be Ford, it can be General Electric, or whatever you can call it. And then the model, of course, the year, because every year there are models coming out of each brand over there, or each over there, since Toyota already or Honda has also brands over there. Then integer, the year in which it is coming out. So now you are having three variables inside this structure, or three inside members inside the structure. And then you make a struct command car1. Now here, if you want to call it car1, totally up to you. You want to name it anything else, but remember, it has to be with the first alphabet over there. You can have underscore over there, or your name, or whatever. Here you have used car1, car2, car3. Car1 is having the brand name as BMW. Again, remember, this is in one line, so you can apply strings over there. Otherwise, if you are accessing car1 dot brand equal to, then it will not be possible. Then you have to use the string copy command, or the function from the chapter number 8. So here you have BMW, Ford, and Toyota. These are the three brands. And then the model, which are the models over there. X5, BMW, very famous brand model over there, the SUV. Ford Mustang, very famous in the 1970s or 80s over there, the Mustang car. And then the Toyota Corolla, which is very famous in Pakistan. You already know Toyota Corolla, the model is 2011, or maybe if you are in 2026, maybe the Toyota is going to release that model maybe real time soon in next few months over there. So you have the three structures over there, and then you can print on these three by using the dot operator. So this is exactly a real life example, and I have already given you example in your class just by using this example over there. And in this example, you have an Hassan and Zainab who are a part of your class, and in this way, now I can add different structures for, let's say, there is another student over there, let's say, and Instead of Zainab, there is another going to be student, let's say there, and Aslan over there. I guess there is no Aslan. So if there is an Aslan over there, and in this way you can have different structures added, and then you can access these each one of the structures and its members of the structures by using this way. So this is one way of doing this, of having structures over there. Then, very importantly, I will just show you another link, which is something very important, tutorialpoint.com, very something very famous for C languages and other languages over there. Kindly go through this one. It's exactly the same thing over there, nothing fancy. Again, the struct command, the member, and the definition over there. Similarly, supposedly you want to store as a book as a structure. So book has a name, it has an author, it has the year, it has the ISBN number. So all this thing, it has a title, you can see it has the author, it has the price, it has the number of pages. And then at the end, you can see over there is a book one. Now, what does book one here means? So here, after declaring the structure, at the end, I have written book one. So what is happening? Here we have declared the structure book one at the end of it. However, you can do it separately also. This is exactly the same thing you have been doing up till now. What you were doing over there, this was a structure over there. Here before it, if I write down as son, comma Zainab. So now Sn and Zainab will be the two structures defined over there. So here before out of the main, you are defining a data type or a super data type, which has many members of the data type included inside. It can also have arrays inside it over there. So don't worry on that one. You can even have that one over there. Then I guess same thing. You can do this one separately as well as you have done over there. And you can write it in one line as I have told you previously. So, and the dot operator, you can access the structure members by using a dot operator. Same thing is being done over here in this one. And apply, remember, you can also find out the size of the structure. Now, this is something very important. The size of the structure will be based on the size of the members of each one of them. Since character takes 1 byte, character here takes 1 byte, but here this will be 10 into 1 byte. Here will be 20 into 1 byte, which means 20 bytes. Double, you already know it's going to take like 4 bytes, I guess, if I'm not, or I guess 8 bytes over double. It float takes actually 4. So it will be 8 bytes over there. And integer always takes like 2 bytes, I guess, or 4 bytes over there. So you are going to find out. Let's say if I just want to run it over there. So it's running it. Let's just say, so you can see now size of the book structure is 48 bytes over there. And here you can see there is a warning specifier because here you are writing percentage D over there. It has to be percentage LD. It's suggesting, let's just say, yes, size of the book structure is 48 bytes. So you can have 48 bytes of the book structure over there. You can count on this one easily on this one, and this will be your structure. So you can fly your size off on this structure as well, totally easily over there. Similarly, again, another example too, you can go through this one yourself. It's something very easy, nothing to be worried about. Same thing, same structures over there, and the output is over here. You can store the data. Similarly, you can copy the structures by using just equalating equal to, or by using the members equal to another member. So you can do that one as well. You can treat them as a variable. Okay, you can treat it by using the dot operator. Dot operator means that sn dot grade is actually telling me that sn dot marks is telling me the marks of sn inside the structure of sn. So now this record structure, it has marks. I can now break this marks into mid marks, final marks also. Then I have quiz 1, quiz 2, quiz 3. Then I can have lab 1, lab 2, lab 3, lab 4 up till lab 14. So this can be grades over there. So I can have many different structures. So understand, I just shown you like 4 or 5 different members of this structure. It can be a lot longer than that as well. Now coming on to the slides, because I have now covered a lot amount of things and I have told you that what is a structure. So just going through it in a very fast way. A structure is a collection of rated variables of different types under one name, as I have told you. And it is, think of it as a container for different types of data. So because in Zanab, you are storing a character, you are storing an integer, you are storing a some other variable, you are storing a string in form of a character array. So you have everything over there. So it is called as aggregates in C standard. And unlike arrays, which store same type, structures can store different types. So you are storing different data types inside one boundary over there. So example is, as I've told you, a student record with name, age, and GPA, just I have told you previously. And remember, arrays are always going to be of same types of element, but structures can have different types of element. As I've shown you over here, this is having integer, or grades. It can have a character array as well. It can have a float. It can have a double or something like that over there very easily. Then next thing, basic structure. I already told you about this thing. This semicolon is a must. Students always miss this thing. It has to be outside the main function. Struct command is also important. It has to be added over there. Here, the struct card is there. And inside this card, now this is something very important. That's why I have not gone through this slide first. Now inside the member of this structure, which is the card, it is called as a constant character pointer face. Now this is something important. Here, what I have, a member of this structure, the structure has a member, it has face, and it is a pointer to a character variable, and it is called as face. Here, this is a suit over there, and it is again a constant point. It's a pointer to a constant data character pointing out. Now, these are the structure members and the variables are inside over there. Then I will come back to this one a little later in the next slide, that how these pointers are actually going to be used, because they are pointers. They're not storing data. They are pointing to a variable which is having some data, and they will be pointing out towards the memory location, of course. Similarly, something more structure example, character first name, again a character array storing your name, supposedly SN being stored over there. SN maybe has a last name something, so it will be also storing inside a 20 array over there. Then his age, then his hourly salary. Of course, you are a student at present, it will not be a salary over there, it will be marks or something like that. So here, if you are talking about a company where you want to actually store one employee's all data, his salary, his age, his date of appointment, date of joining, his first name, his last name, his address or something. Everything can come inside it. This is called a structure. I hope now you're getting the point of why we are using structures over there. So here the structure name is employee, and it contains 4 members, 2 character arrays, which are strings storing the strings, one integer, one in double. And each member has a unique name over there. Then next thing, very important, a structure that contains a pointer to its own type. Now this is a little confusing, but understand this one very clearly over there. Self-referential structure. You have a structure, and inside it, it is pointing out to its own structure. How? You can see over here, struct employee. Now remember, struct employee, if you have made a structure outside your main function, let's just go back on this one. You have a struct record over there, and when you are making struct record SN, so SN is making a structure type record, and it has marks, quiz 1 marks, quiz 2 marks, quiz 3 marks, and grades over there. But when you are going to see over there, the last data type over there, the last member of this structure, this is struct employee static manager PTR. So this is a pointer to another employee. So now remember this thing here. This is a structure called employee. An employee will be having a first name, last name, age, hourly salary, maybe some other data as well. But here, this is not here. Now, the last point or last member of the structure is another employee, which is a manager ATR. And now, why this is that? Because if he's an employee, he may be reporting to a manager pointer. So this is exactly the same thing you are appointing over there. So that's why this is a pointer, because every time you are working inside an organization, you are reporting to some boss. So maybe your employee is working to a manager. Manager is pointing out to a higher hierarchy staff. A hierarchy pointing out to a CEO. A CEO is giving to a director. A director is going to be pointing out to a chairman. So inside each structure, you are pointing out a structure to another one. So it's just like this thing. Just imagine this thing. If you go to another station, you enter your number of CNIC number over there, and your CNIC number points out to another structure of your father. And your father's structure points out to your grandfather. And your grandfather's structure points out to a great grandfather. So here, this self-referential structure here means that you are referring to another structure of the same type, but it is a manager pointer. So it's a pointer to another employee, because of course that manager is also an employee. It has the same, it will be also having a first name, it will be having a last name, it will be having an age, it will be having an hourly salary, of course, on the higher side, because you are a lower rank person over there. So this manager PTR will be a pointer to that. So whoever has hired you, whoever you are reporting to, that will be the manager pointer. So very important rule, it can contain a pointer to its own type. Then it cannot contain a variable of its own type. It will be compilation error. So you cannot have a employee inside. It has to be a pointer inside over there. It cannot contain a variable of its own type. You can't write structure employee, let's say XYZ. You can't do that. It has to be a pointer to another one. So you can build linked data structure. I told you this linked data structure. This is a data structure algorithm course which will be coming on to you in maybe like 6 months or like 1 year from now on. And here this structure thing will be in very much important factor over there. And I told you, just like a tree structure, when you go to another station, you are linked to your father through that structure, and then your father is linked to your grandfather, and then grandfather is linked to your great great grandfather. So here this is one way. I will come back to this self-referential or pointer structure a little later, but I hope you have got this idea that you are pointing out to another employee who is, and you are doing it by a pointer over there. Remember, the word is struct inside over there, employee, static, manager pointer. So you are pointing out to another structure of another employee, but using the pointers. Okay. Now, creating structure variables, we already done that over there. You have struct card, my card, it's a single variable. Then you have struct card. Now, up till now, what you were doing over there, now remember this thing, what I was doing, struct record SN, struct record Xanav, struct record epsilon. Now I would have to write down 100 times. No, that's very difficult. I can do this thing very easily. Struct record over there. And here, supposingly, just like this slides over there, let me just show you the slides first, and then I will go on. Here we have written deck 52. So it's an array of 52 cards. An array of 52 cards, I inside over there, let's say this will be PF, brackets open, since you are, I guess, 98 students over there. So I have 98 over there. Now I don't need to write down each one name. So now roll number 1, roll number 0, I guess, is not going to be there. So of course 0 I have to eliminate it, because structure is always going to start from, array is going to start from 0. So I have 98. From 1 to 98, I have now structures. So now here, if I want to write it down, this will be PF. Let me just say PF1 dot marks equal to 10. This will still work. And why I'm doing this? Because I don't need to make this struct commands write down 98 times or 100 times, because you are like 98 students in the class. I can do it. I know 1 is always the registration number. So PF1, registration number 1, what are the marks of it? Stored. Quiz 1 marks stored, quiz 2 marks. And the advantage of this is this thing, that if I want to now, I can use a for loop over here. Let's say int x equal to 0 and x is less than 99, let's say, and x is plus plus. And let me just now change it. And here inside, I can write down x. So now I will just compile it, and it will just now put all of the data inside over there, pf x dot. So all the members from 1 till 98 will be having the marks defined by a simple for loop. So you can see very easily over there that you are having your structures defined. Now here I have defined how many structures? 98 structures over here. So in this way, you can define also as well. Now, what is this? Struct card, static card PTR. This is a pointer to a card. Remember, this is a pointer to a card. Just like the same thing I was showing you over there, self-referential over there. I will come back to this one most probably in the next video over there. But remember, this is also possible over there. Similarly, if you want to write down the struct card, I told you already, you can have it written down here, or you can write down separately over there by using the struct card my card, or struct card deck 52, or struct card static card PTR. These are two ways. You can define it like this, or you can define it like this. And think of the structure beginning as creating a blueprint. Creating variables is like building houses from that blueprint. So you are first of all making a blueprint, and that blueprint is made over there in form of a structure over there. And then afterwards, you are assigning rooms, or you can call it the members of that structure over there. So Ahsan, Zainab, or Aslan, they are now structures made on that structured data type over there, or super data type over there. Or I have a variable array which is called as PF98, and it is now accessing all that one over there in this part. So this is one way of the doing it. Now, just to give you an idea, I have a struct card blueprint. My card is another structure. Deck 0 is another one. Deck 1 will be another one. Deck 2 will be another one. Deck 51 will be another one. Okay, because remember, when you are talking about arrays, this will be an array from 0 to 51. 52 is never the position. I hope you remember that from the array. Whenever you are defining an array, 0 to n minus 1, it goes on to that one. So it defines, creates no memory. Variable creates actual memory. Remember, whenever you are defining it, you're not having a memory. We're just assigning it. But when you are going to create variables, they create the actual memory over there. Then, of course, if you want to define it again with tag names over there, you have structure card, my card, same thing. I've just shown you on the slides or on the over there. So you can create a variable anytime now. So now my card is created. My card is created. Now inside my card, I can do it with this way as well. Then if I want to now operate on that structure, that is going to be, let me just show you again. So you can do that one. You can apply dot operator. You can apply the address of an structure. You can access the structure members by using a dot operator. You can use the size of, we have just seen that. That was the case in that example on the website. And then you can have the struct card, my card is equal to an empty as well. You can zero initialize as well. This is also possible in one line. And then one thing very important, you cannot compare structures. You can't say Sn is equal to Zainab. No, you can't do that because it has subtypes inside it. It has an integer, it has a character, it has a float, it has a double or something like that, or maybe an array inside it. So you can't compare them by equal to or not equal to command. And assign structures of different types, that is also not possible. Perform arithmetic structures on this one, that is also not possible. Then why can't we compare structures? Very importantly, this is a very important thing. Whenever you are comparing structures, you are having memory alignment creates holes, because whenever your variables are going to be stored inside the memory, they are not stored in sequence. Because whenever you are storing this thing, let's say you are storing marks, it's an integer, you are storing quiz one marks, integer, and this grade. So when you are arranging byte wise over there will be some empty spaces which are called as holes over there. Those holes are written over here in this slide. So when you have a C variable, then you have a hole, and then you have a 97. So even if the data is the same, holes may contain different garbage value. I guess I've already given you the answer that if you are not initializing it, this 1 or -1, this zero is being, now previously it was 1, now it is 0. You can see now, previously in the start of the part, it was 1, now it is 0. So it is garbage value being printed because I have not initialized it over there. It is printing the garbage value from the memory over there. So you can't compare structures because they are holes. Holes here mean not physically holes. Holes means that the structure may be empty over there or not initialized over there. So you can't do that one inside structure. So yes, you can compare individual members of your structure. You want to compare the marks of Zanab with the marks of SN. Yes, you can do that, but you can't do that for the whole structure over there. So it will give you garbage values over there. Very importantly, I guess some suggestions over there. Let me just go through this one. And you have the consider structure over there. It has two pointers over there. Now, which statement is false? Let's just see over there. Struct introduces the struct definition. Yes, I guess it's true. Name is the structure tag. Of course, member must have unique names. I guess this is the wrong. It has a unique name. Of course, they have the same different names. All statements are true. Which one is wrong? Name is the structure tag is, I guess, over here. In fact, sorry, I'm wrong over here. Sorry on this part. All statements are true. I guess all are true over here. Yes, all four are true over there. So all these statements are true over there. Let me just go through them again. Struct introduces a structure definition. We already know struct is a reserved word. Name is the structure tag. Here, remember, name is the name of the super data type which we are using over there. Members must have unique names. Of course, yes, true. And all statements are true. So all four statements are true. That's why D is true. Then, which is not a valid operation on structures. Accessing structure variables to structure variables of some data type. This is totally okay. Dereferencing a struct variable. Dereferencing by using the static operator, which is the pointer operator over there. Accessing structure variables, yes, you can do that. Using size of a structure over there. You cannot dereference a struct variables. You cannot dereference a struct variable because it's not a pointer. Remember, you can take its address with the AND, but you cannot dereference it by using a, so you cannot use a pointer on a structure over there because its memory address is going to have null situation over there. So you cannot dereference a struct variable. Understand this thing, you will get to this thing what I'm talking about, because structure itself are memory arranged over there. You don't need to find out its memory value by using the pointer operator. You don't need to do that. Yes, you can apply the AND operator to find out the address, but you don't need to apply the static operator over there. Then very importantly, I guess I've already told you, structure card, my card is equal to 3 and hearts. Now, previously what we have done, just let's go back on this one. You have a structure name card. This was actually this one was here. Yes, this was card. It was having face and it was having suit. Now, if you see over there, this was const character static face. It was a pointer to a character inside the memory, and it was constant data. So now when you are going to initialize it, they are initialized in this slide over there, and you can see struct card, my card. So my card is a member of the structure card, and it has two strings stored inside it as a constants, which is 3 and hearts. 3 will be going on towards the face, hearts will be going on to the suits. Now you understand why they are called as pointers over there. They are not self-referential pointers, which I have talked about in the last part. These are the pointers to the memory storage as strings inside your memory. I hope you got this thing. Then struct employee over here, and if you just apply this thing, John over there. Now first name will be John, last name will be null because I've not initialized it. Age will be equal to 0. Hourly salary will be equal to 0. So remaining members automatically sets to 0 or null. But again, better way, make them equal to 0 or null. Otherwise, it will be problematic for you. Then another full example, I guess nothing to understand over there, something very important. You have a structure employee, EMP1. You have John, first name, Doe, last name. This is the same structure from the last few slides over there. Then you have 30 as, I guess, the age, and this one is the hourly salary over there, of course, in dollars over there. And then you have partial initialization. Then you have Jane and Smith. So this Jane and Smith will be the first name and the last name for employee 2 over there. Age will be 0, hourly salary will be 0. Zero initialization means that it will be using the parenthesis over there. That you make a structure. Let's say, supposedly, there is a roll number inside your class that has been, I guess, I don't remember its roll number, I guess roll number 29. He was here. He has been here from the last 2-3 weeks, I guess 4-5 weeks now. But before the mid, he was not here. So it was an empty case in that case. So it will be structure employee, whatever that roll number or whatever that employee, he was joining not late over there. So it will be an empty one over there. So it will be all members will be set to 0 or null. Then external variables, outside functions, again automatically initialized to 0 over there. So this is again automatically initialized to Always initialize your structures to avoid garbage values. As I've told you, again, the same case in my case, when I was making this without initialization, that's why it was now printing 0. Previously, it was printing 1 over there. So I hope now you've got this thing. Then one, two, three more questions like, yes, true, false. If there are fewer initializers and members, the remaining members are not initialized. False. You've just done it. They are initialized to 0 or null for pointers over there. Uh, then another question over there, I guess question number 2, you can assign structure variables to other structure variables of the same type. False. Oh, sorry, yes, this is true. You can assign structure variables to other structure variable of the same type. Of course, S2 can be equal to S1, S1 can be equal to Zenab. So this is true. This is a valid operation. You can do that one. And how you are going to two ways to access the members. I was already told you using the dot operator. You can see over there, my card dot suit. You will be printing ace if you print my card. Now, another way of doing it instead of the dot operator given in your book, not on the websites, is by using this arrowhead over there. This is the dash symbol and then the greater than operator. This also tells you, I guess this is much easier for you to understand over here, instead of using a dot operator, that card PTR is the structure and suit is the type of that structure. Just like in integer, you make int x. So x is a member of the integer data type family. So here suit is a member of the card PTR over there. So card PTR dot suit will be giving you, so it will print spades over there. So here you will having card PTR to suits over there. But before that, since you are using this thing, so you are using this thing over there with the structure pointers. So you have to now call it as the card PTR equal to and my card. Remember, this is structure card PTR equal to and my card. Here you are using and, which is the address of the my card. This is the address of the my card. And here this is wrong over. This is not the question mark over. This is actually the same symbol over there. This one dash and the greater than symbol over there. So this is going to be used with structure pointers. And if you are having structure variables, then you can use this thing. Remember, if you are accessing members which are not pointers, then you have to use the dot operator. And if you are having pointer operators inside or structure of pointers over there, then you have to use this thing over there. You can do that easy. Try to use this one as an example over there, and then we will come back. So this is the arrow operator. Again, the same thing, arrow operator over there. You have card PTR. It has the suit, so it is the arrow operator. This is easier to read. And then you can use this same as static card PTR and then the brackets open, because first of all, the dereferencing has to be done, then dot suit. So first of all, the dereferencing plus the dot operator, same thing. So these two are exactly the same thing over there. No change. But again, if you do it something like static card PTR dot suit, then this will be wrong because dot has the higher precedence. So it will be first of all card PTR dot suit, and then the dereferencing operator will be added. Just to be wrong. So the correct is this thing that apply the two parentheses and then the dot suit. This is a dereferencing first, and then you can use this the best clear and simple overlay. If you want to avoid this thing, then you would card PTR dash and the greater than symbol, or you can call it the arrowhead over there. I normally call it as the arrowhead over there. So arrowhead suits. So this is the best, clear, and simple. Always use. Remember, this is the wrong one over there. This is actually the greater than symbol with pointed. It's clearer and safer over there. Then, very importantly, space conventions. Something very important. Do not put space in between the dot operator or the arrowhead. If you put a space over there, this will be a syntax error over there. So you don't have to put the space below, before or after the dot, or before or after the point, or between the pointer over, sorry, the arrowhead over there. I don't call it the pointer, it's actually the arrowhead. I call it as the arrowhead over there. So this is a syntax error over there. So the spacing convention has to be done very carefully. You don't need to put space over there between the over there. Then a complete example. And in this complete example, you can see before the main function, I have a structure, and this structure is const character static phase, const character static suit. So these are two pointers inside the structure. Of course, they will be pointing out to a memory and there. So here structure card my card. So my card dot face is equal to ace, my card dot suit is equal to spades. So ace and spade will be stored somewhere in the memory. So they are going to be having storage over there. But before accessing them using the card pointer over there, I have structure card static card PTR equal to and my card. Why and my card? Because and is the address symbol of it over there. And in this way, you are accessing this one. So I hope you got this one. In next part, I will be discussing the union and the type def of this thing, and then we will discuss this in detail. Please kindly try to go through this 22 slides over there, and then we will talk about later on.